Imperative logic is the attempt to give a formal logical treatment of imperative sentences, such as commands, requests, instructions, or advice. Typical examples include close the door, open the window, do not lie, or turn left at the intersection. Unlike ordinary indicative sentences, imperatives do not describe how the world is, but rather aim to influence how it should be. Traditional logic has focused almost exclusively on indicatives, which are true or false, and has largely ignored imperatives. Imperative logic challenges this restriction by asking whether there can be a genuine logic of commands. The central motivation is simple: arguments containing imperatives sometimes seem valid. Consider, post the letter or destroy it. Do not destroy it, therefore post the letter. This reasoning appears compelling, yet classical propositional logic cannot account for it, since imperatives lack truth values. Imperative logic aims to explain such cases without reducing imperatives to hidden indicatives. Many philosophers and logicians have argued that excluding imperatives leaves logic incomplete. Natural language reasoning often mixes statements and commands, especially in practical reasoning, ethics, law, and everyday instruction giving. If logic is meant to model rational inference in general, it seems artificial to ban imperatives from the formal framework. Furthermore, some inferences involving imperatives closely resemble familiar valid forms, such as disjunctive syllogism, conjunctive syllogism, or modus ponens. We have already mentioned one example. Here are two more. Do not combine drinking and driving. Drive. Therefore, don't drink. If the milk is boiling, remove it from the heat. The milk is boiling. Therefore, remove it from the heat. Denying that these are logically valid merely because they involve imperatives appears ad hoc. Imperative logic seeks to preserve these intuitions while respecting the fundamental difference between commands and assertions. The language of propositional imperative logic includes two kinds of basic sentences: indicative sentences written with ordinary letters, P, Q, R, etc. These are true or false. Imperative sentences written with underlined letters, P, Q, R, etc., where these letters are underlined. These lack truth values. Both kinds of sentences are treated as well-formed formulas. Importantly, complex expressions can be built from both kinds using familiar connectives, such as negation, conjunction, disjunction, conditionals, and biconditionals. Here are some examples. Don't do A and do B, or do A and B, do A or do B, or do A or B. Don't both do A and do B, or don't combine doing A with doing B. You are doing A but do B. You are doing A but don't do A. If you are in fact doing A, then do B. Do A only if you are in fact doing B. This mixed syntax reflects the way real arguments often combine factual claims and commands. Since imperatives are neither true nor false, validity cannot be defined as truth preservation, as in classical logic. This has led some to doubt whether imperative logic is possible at all. However, proponents argue that truth preservation is only one way of understanding validity, and that other semantic notions may be equally legitimate. Several semantic approaches have been proposed, including the obedience view and the threat view. The obedience view says that an imperative argument is valid if doing what the premises prescribe necessarily involves doing what the conclusion prescribes, given that the indicative premises are true. The threat view analyzes the imperative do A as either you will do A or else S will happen, where S is some kind of sanction or bad thing. Both views face serious difficulties. For example, according to both views, the following argument is valid: if you work hard, give yourself a gold star. Work hard, therefore give yourself a gold star. But this argument is intuitively invalid. Maybe you do not, in fact, work hard. A more promising approach seems to be the correctness view. According to this view, both indicative and imperative sentences can be evaluated as correct or incorrect. even though only indicatives are true or false. Roughly speaking, an indicative sentence is correct if it is true. An imperative is correct if it is appropriately issued in the given circumstances. Correctness is not a psychological notion according to this theory. For example, it does not depend on whether an order is obeyed. Instead, it is a normative or structural property of the sentence relative to a situation. This allows us to define semantic notions uniformly across both sentence types without reducing imperatives to disguised assertions. On the correctness view, logical consequence is defined in terms of correctness preservation. A conclusion follows logically from a set of premises if, and only if, in every situation in which all premises are correct, the conclusion is also correct. Similarly, an argument is valid if, and only if, correctness cannot be lost when moving from premises to conclusion. This mirrors the classical definition of validity but replaces truth with correctness. Importantly, this definition applies equally to arguments involving only indicatives, only imperatives, or a mixture of both. Several proof methods have been adapted to imperative logic. Correctness tables, analogous to truth tables, track correctness values instead of truth values. Natural deduction systems where rules govern how imperative and indicative sentences may be inferred. Semantic tableau methods extended to handle correctness conditions rather than truth conditions. These methods show that imperative logic can be formal, systematic, and rigorous rather than merely informal or heuristic. Propositional imperative logic can be combined with other logical systems. It can be extended with quantifiers, predicates, terms, etc. In such a system, A, X, Y, where X is underlined, can be used to say X, do A to Y. For all X, A, X, where X is underlined, can be used to say let everyone do A. And there is an X such that A, X, where X is underlined, can be used to say let someone do A, etc. Modal versions allow reasoning about commands that must or may be followed. For example, the exclamation mark followed by an underlined A can be used to say that A must be the case, and the inverted exclamation mark followed by an underlined A can be used to say that A may be the case. Moreover, some philosophers argue that deontic logic, the logic of obligation, permission, and prohibition, can be built more naturally on top of imperative logic than on standard propositional logic, since norms are closely related to commands, and since this approach can be used to avoid several so-called deontic paradoxes. Imperative logical systems typically aim to satisfy familiar metalogical properties such as soundness and completeness with respect to their correctness-based semantics. However, results vary depending on the exact system and connectives used. Caution is needed when transferring classical results, since the underlying semantics differs. Imperative logic remains a controversial area. Some philosophers deny that imperatives can be part of logic at all, claiming that logic is essentially truth-based. Others argue that this view is too narrow and that imperative logic captures an important dimension of rational reasoning. Whether or not one ultimately accepts imperative logic, it raises deep questions about the nature of logic, validity, and rational inference beyond truth alone.